My name is Yogesh. I work for Kanchi Data as Director of Solutions Engineering. Ansible Tower itself has a built-in HA capability. That means you can run more than one Ansible Tower nodes and they work in quorum, and you always have high availability for Tower. Underlying database, which is PostgreSQL, it doesn't have HA capabilities as default. Our product is going to provide high availability by creating a resilient database. This database is going to provide automatic failover. In case one of the node acting as a primary database node, it fails, it can automatically fail over to replica node and make it a new primary. Not only that, it can also heal that old node and make it a new replica. Crunchy Data is Red Hat certified and recommended technology partner. Being a certified Red Hat technology partner, it brings confidence in our product. Using Crunchy Data's high availability platform enables maximum uptime across single and multi-data center architectures. Now that you have heard about benefits of using our product, let's look at the live demo. I'm going to go over overview and live demo. When someone wants to run PostgreSQL in an enterprise environment, they have a lot of things to complete. Provisioning, create, destroy, configure, administrate, and upgrade your cluster. High availability, that means you need uptime. Scalability, failover management. Disaster recovery, that includes backup, restore. And if you properly plan your disaster recovery, you can have your backrest repository stored in S3 bucket or synced across data center. So in case if you have full data center loss, you can still recover. Monitoring is crucial. Unless until you know cluster insights, you don't know how is your cluster behaving. So you need proper cluster insights and health checks. On management front, you need performance, access control, user connections, etc. So all these things will add up a lot of stress for IT admins and DBA. If we just talk about a single PostgreSQL cluster, you still have a lot of things to do, like setup, which includes configuring a software repository, installing software, initializing database, configuring, modifying your PostgreSQL config file periodically for performance tuning, etc. Adding your authentication rules in PTHPA file, periodic security patch management, user management, database management. So all this adds up to a lot of work for IT and DBA team. What if I said that we can create a multi-node PostgreSQL HA environment for Ansible Tower in one step? What we'll be doing is executing Ansible playbook command with an inventory and playbook. So let's look at a live demo. I have my 3-node Ansible Tower, my 3-node HCD, HA proxy, monitoring, 3-node PostgreSQL, and backrest node up and running. They all are running Red Hat Linux 8, and here's my command line to execute a playbook. I have defined my inventory and my playbook along with some of my extra variables. At this point, let's launch this. While this is running, let's quickly take a peek at what changes do I need in my inventory file for Ansible Tower. Let's get this inventory file. So my 3 Tower nodes are defined out here. I don't need anything database section because I'm using external database. I have also set Ansible become equal to true because I'm not connecting as a super user there directly. My admin password for Tower is set, and here I'm going to define my endpoint for Kanchi HA PostgreSQL. In this case, our endpoint is going to be HA proxy node. My Postgres is going to run at 5432. Database name AWX, user is same AWX, my password is defined here, and I prefer to use SSL communication. We cannot run this setup until our HA setup is complete. Let's look at HA setup while it's going on. Let's look at some other slides and talk about Crunchy HA PostgreSQL, what it is. Why do you want to use Crunchy PostgreSQL? The first thing you get from Crunchy HA PostgreSQL is automation. We can create highly available PostgreSQL cluster in single or multi-data center environments. You can standardize your environments. PostgreSQL environment provisioning and management process can be standardized so that you can create one or more similarly designed PostgreSQL HA clusters. It will maximize your flexibility. You have an option to pick synchronous versus asynchronous replication, number of nodes, where your HCD resides, etc. etc. You can also uniformly apply all your compliance rules on all Postgres cluster. That's the beauty of automation using Ansible, that you can take a playbook and apply it to all of your nodes. And it's based on trusted components, and all those components are 100% open source. So what are these components? First one is Crunchy certified PostgreSQL. It's a common criteria EAL2 certified. We also published a STIG benchmark, which is a secure technical implementation guide used by DISA. We have also written CIS benchmark. It's used more towards the commercial side. PG Backrest, it's designed to handle multi-terabyte scale databases. It can do backup, restore, point-in-time recovery, etc. PG Monitor, robust monitoring, key database health metric collection service. PG Bouncer, connection pooler and state manager. For Tower, we don't use PG Bouncer, but it is available. HA Proxy, perform durable TCP proxy and load balancer. Patroni is brain and heart for HA. It's a HA framework for PostgreSQL. Patroni is the one who is going to manage availability of PostgreSQL and do automatic healing, promotion, etc. Last but not least, etcd. It's a distributed key value store, also used by Kubernetes OpenShift. So if we take all those components discussed on previous slide and put in a pictorial view, this is what you're going to get. We have one or more tower nodes running HA mode. They are going to talk to HA proxy. HA proxy is going to redirect all the traffic to active PostgreSQL node. On active PostgreSQL node, we have Patroni running. Patroni is managing PostgreSQL. As Patroni is managing PostgreSQL, it's going to utilize etcd for storing critical information, as well as Patroni is going to also utilize etcd for electing leader. PG Monitor is going to collect monitoring data from PostgreSQL and operating system, and that data will be stored by Prometheus. And Grafana can pull the data from Prometheus and provide icon view. PG Backrest is going to do two things for us: periodic backups and write-ahead log archiving. You have choice to pick and choose your storage for Backrest repository. It can be S3 bucket, NFS, or locally attached disk or SAN. In case anything happens to this node, Patroni will execute an automatic failover, which will result in leader election, etc. And one of the healthiest node will be picked as a new read-write node, and HA proxy will redirect all incoming traffic to that node, and all this happens transparently. So what do you get with Crunchy HA PostgreSQL? You get automated deployments. We have created Ansible roles and playbooks which are going to help you with a lot of things, setting up your cluster as well as managing over time, like security patching. You can easily upgrade PostgreSQL minor version using our playbook. It can also help you do major upgrades for PostgreSQL. We have playbooks to take backups, dumps, etc. And there are a lot of other playbooks available. Patroni is going to do failover management, promotion, and healing. So basically, we are creating a resilient database. We also get advanced disaster recovery capabilities using PG Backrest, and if you have properly defined your DR storage, you can recover even after full data center loss. You also get connection pooling, which we will not be using for Tower because Tower already has a built-in connection pooler. Load balancing, always redirect traffic to known primary using HA proxy, monitoring and alerting based on PG Monitor. When we say automated deployments, what we're talking about is Ansible. Set up and manage everything using playbooks. It's going to deploy required components. It supports full HA stack. It's going to configure required services, example SLNX, opening firewall ports, setting up PostgreSQL, setting up HA, DR, monitoring. On HA side, as and when it's detected that the primary node went down due to some issue, remediation kicks in, where Patron is going to pull the plug on the defunct primary, and it will promote one of the best candidate replica that is farthest ahead. Healing also kicks in, as and when you fix and repair your old primary, it can recreate that node as a replica and attach it back to cluster. Adding new node is not a big deal. You can just update your inventory and execute your playbook, and it will add it as a new node. For disaster recovery, we heavily depend on PG Backrest. It's a leading backup and restore tool for PostgreSQL. It can handle multi-terabyte scale databases. It's very feature-rich. Full incremental differential backups are supported. Multi-threaded backup and restore operation can be executed. Supports for point-in-time recovery. Built-in backup integrity validation, compression, encryption, rotation, archive expiration. It can do a lot of operations in async manner like archive, get, and push. Authored, maintained, and supported directly by Crunchy. Monitoring is based on PG Monitor, which utilizes Prometheus, Grafana, and Alert Manager. PG Monitor is designed to capture PostgreSQL cluster health along with operating system, HCD, and other metric. Prometheus is going to do the metric collection from exporters configured and installed by PG Monitor, and it's going to do alert processing. Any of the alerts that are not matching thresholds, it's going to hand over that to Alert Manager for alert dispatching. Prometheus is also going to do metric distribution so that Grafana can query data from Prometheus and provide metric visualization. Authored, maintained, supported directly by Crunchy data. Let's take a quick look at what's going on with our setup. Okay, our setup is completed, so that means our HA cluster is up and running. At this point, we can fire up our setup script for Tower. So I'm going to execute this setup.sh provided by Tower. I'm installing 3.7-1. So while it's running, let's finish up our presentation. So we have built Crunchy HA PostgreSQL for scale. You can have a HA cluster in single data center where you have a single cluster and all these infrastructure services are combined with it. If you want more of these nodes, you can have more HA clusters running and they can still piggyback on the same infrastructure services. If you are a big enterprise environment, you don't want to be constrained in a single data center environment. That means you need some sort of a disaster recovery plan. That's where our multi-data center concept plays a big role. You have an active data center, that's where your tower is running, talking to HA proxy, and it's a similar setup like previous slide. On the right side, what you're going to see is identical setup. Here, tower is not running, it's ready to go. But our database is running here as a replica. It's a standby database. This side of database is going to keep updating itself from active data center, and in case if active data center goes down, you can execute a playbook to promote this, and after promotion you can start your tower instance out here and you are up and running again. You may ask a question, so what happens during that time? Can I utilize both data center at the same time? There is a possibility, but our design is going to be a much more complex design compared to this one, and we have to think about some other constraints too, like your network latency and other things. In this design, what we are doing is we are stretching one single Postgres cluster across two data center. This also demands for a third HCD node, so it can act as a quorum node, so we don't get into a split brain scenario. There are a couple other things here, like any failover happening, it can be that the primary might be running in data center 1 or 2. Applications can run on both sides, and the application on the second data center where there is no primary, all those writes are going to happen to the node to the data center where primary node is running. So that means we are writing across the data center. This kind of resembles active data center because my application is active on both sides. I'm not saying that database is active or multi-master. What I'm saying is both side of applications can run actively. So Ansible Tower and Crunchy Data, we are Red Hat certified partner for Ansible Tower. And here's a note from Carl Benson, who is a Red Hat Senior Product Manager for Ansible Automation. Here is a quick glance at our customer list who are using Crunchy HA PostgreSQL. Crunchy HA PostgreSQL is not tied just to Tower. You can use it for other purposes too. Okay, let's look at the live demo and see how is our setup going. Our Tower setup is still going on. Meanwhile, let's look at our monitoring node. So here's my monitoring Grafana front end. I'm going to log in as a default password, and I'm going to not change my password right now. And let's look at the overview view. On the overview view, I can see all of my nodes are up and running. Let's click on one of the node and open a new tab, and I'm going to switch to a couple other dashboards. PostgreSQL overview dashboard is available, where I can see that my primary node is my PG3 node and I have 2 replica nodes running. Let's click on this node and open another tab. On the OS front, you get a lot of information. Let's switch back to last 3 hours. Our system load, CPU usage, memory, swap, file system usage, etc. And there are further drill downs available if you want to get more details. My main focus is PostgreSQL, so let's look at PostgreSQL. So let's look at the last 2 hours out here. So how is my connection going? My idle in transaction, active, and my max connections. How is my database size overall? If I want to look at per table sizes, I can drill down further here and look at the per table sizes. My transaction per minute, my replication byte lag, or my replication in lag in time, my cache hit ratio, commit versus rollback, my create, read, update, delete stats, my lock information, conflict deadlock information, buffers, my transaction wraparound, emergency vacuum, total wall size, vacuum analyze, activity rate. These are some of the default charts that are available. You can also drill down further here, and if you want to look at some other things like PG backrest or query stats, if it is enabled, etcd, bloat, your crude detail, your file system details, PG backrest, bouncer, and all these dashboards are available here. Here is one of the latest addition to our PG monitoring, where it's providing you top end queries which are performing slow. So here you have top end queries shown based on different sorting orders. Okay, so I'm going to close this one and let's go to one of this tab and open. Let's look at our Tower installation. So our Tower installation is still going on. Let's wait for it to complete. Okay, so Tower setup is complete at this point. I'm going to open up web console here and accept my self-signed certificate. Here's my Tower. I'm going to log in as an admin and admin password. Okay, so our Tower instance is up and running and it's talking to Crunchy HA PostgreSQL. Let's see how it's going to handle any failover and other things. So here is my connection, I'm going to connect to one of the node, and I'm going to execute a CLI command to see what is my cluster status. And I can execute same thing using a playbook too. I do have a playbook which I can execute here. And we're going to see similar information. So at this point my leader node is 3, and we did verify same thing on this dashboard that my primary is PG3. Okay, what if I execute a switchover? I can easily execute a switchover playbook which is going to switch leader role from PG3 to one of the node which is going to select based on leader election. Let's execute this one. So as you see, this is the current state. It's executing a switchover. After switchover, couple things happen. First thing, a plug has been pulled from this primary. A new node PG1 has been selected as a leader, as you can see here, and it's already up and running. Let's look at list again and see what happens next. Now you can see this node has already joined cluster, and they both are on the same timeline, as well as automatic healing kicked in, and it has reconfigured my third node to join this same cluster. Let's go look at the tower and see how it's functioning. Okay, I don't have any issues, any database issues reported here. So my switchover was transparent from tower point of view. I'm going to leave it here and switch back to one of the other nodes. Let's connect to third node, which is a replica node. What if I lost my data volume? I can simulate that easily using RF for my PostgreSQL data folder. So as soon as I execute this command, let's print date first before removing everything from this data folder. So I cleaned up. So at about 2144, I have cleaned up. Let's go back and execute list command again and see what happens here. It's not magic, if I can say that. So what happened behind the scene, Petroni detected that third node, a replica node, had issues, and it automatically executed a backup restore process using pgpackrest. That backup was restored, this node was reconfigured and attached back to cluster. Let's go check tower again. Yep, tower is still working. I don't see any errors being reported here. Let's go back to my current active node. So right now my active node is PG1. We can verify from list. What if I have data volume loss on my primary? So I'm going to remove everything from my primary PostgreSQL node. That means I have lost my primary node. In this case, Petron is going to detect that, okay, primary is not working. Can it recover it? Recovery is not easily possible, so it's going to execute a failover. If I go back and execute a list command here, so here's my member list playbook. I'm going to re-execute that one, and as you can see, this was detected that this node is down, and luckily PG3 was selected as a leader again, and it's running, and automatic healing is going to kick in and reconfigure this third PG1 node as a new replica again. Let's look at our list one more time. Okay, there you go. And let's look at the tower again. Okay, everything is working smoothly. What we have learned from this demo is that Crunchy solution brings in automation for HA provisioning. It also brings in HA itself so that your database is always up and running, along with disaster recovery so that even in case your whole data center dies, you can recover from it. Thanks everyone for watching demo. My name is Yogesh Sharma, Director Solutions Engineering at Crunchy Data. Crunchy Data and Red Hat enhanced uptime for your automation.